So this question provides us with this graph here. I'm always a big fan of paying attention to where the intercepts are. It looks like they're already labeled in this particular graph. We have a y-intercept here at 4 and an x-intercept here at 5. The question goes on to say, in line L, line L is shown in the xy plane and the point with coordinates 2, c. So 2, c would have to be right here, right? Because that's where x is 2. So c, whatever it is there for this to be 2, c. The point with coordinates 2, c is on line L. What is the value of c? Well, I'm not 100% sure, but what I can do, I'm not 100% sure visually at least, but what I can do is take these points that are provided and create a equation for this line. So whenever I'm creating an equation for a line, I like to use y equals mx plus b. I know that my b value here, my y-intercept is 4, so this becomes y equals mx plus 4. I'm going to then use this point here, which is the point 5, 0, to plug in to my x and my y so that I can solve for m. So y equals mx plus 4 turns into 0 equals 5m plus 4. And subtracting 4 from both sides, I'd have negative 4 equals 5m. And then dividing both sides by 5, I have m equals negative 4/5. So my equation becomes y equals negative 4/5 x plus 4. So that is the equation of this line. And now, because I'm wanting to figure out what c is basically the y value. So c is y when x equals 2. That's how we interpret this. So if x were equal to 2, so let me just write this down again, y equals negative 4/5 x plus 4. If x equals 2, this just becomes y equals, in fact, let me just write it this way, c equals negative 4/5 times 2 plus 4. So c equals negative 8/5 plus, we'll call this 4 over 1. In order to have like denominators, I'm going to multiply my top and bottom here by 5, which makes this a 20 over 5 instead of 4 over 1. And then negative 8 over 5 plus 20 over 5 is equal to 12 over 5. So there's my answer for c. c is equal to 12 over 5.